In this video, we're going to talk about how to determine what tests to do when you want to compare the centers of to some value or of two or more groups or samples. And I say centers because instead of means, because there'll be some cases when it's more appropriate to compare medians, and we'll talk through those here. But in the simpler cases, we'll be comparing means. What we need to do, first of all, is we need to determine whether we just have one mean being compared to a value. That's the simplest case. It's not often done in real life, but it is often the first thing taught in a statistics course because it's fairly simple. Or whether we have two means we're comparing from two independent samples. So maybe we have a group of males, we have a group of females, and we want to compare the mean test scores for the males versus the females, and so forth. The next case that we're going to be looking at is if we have two, but it's paired data. So maybe we have sets of twins, maybe we have husband-wife pairs. So in this particular case, we may have males and females again, but they pair up in some way, one husband to one wife, or maybe it's two measurements on the same person, like a pre-test, post-test, or some measurement on the left hand, right hand of the same person. And so in some way the data pairs up. In this case, when we have paired data, you must have, either two columns of data that are the same length, or else it could be all in one column and it tells you which pair they belong to. However, both groups need to be the same size, where they don't necessarily have to be in this particular case. Now we have the situation in which we have three or more groups, and again that can be either independent, completely independent. So maybe have three gender groups, three ethnic groups, three different schools, three something that I'm going to be comparing to each other, that individuals within the groups don't line up together. And then we have the case that's equivalent to pair, but groups of three or more. We call that repeated measures. In that particular case, maybe I have a pre-test, mid-test, post-test on the same person, three measures on the same person, or I could have triplets, okay? I have three or more that do group together in these groups of three in some way that you have accounted for in the data, okay? So we have these basic three cases that are, five cases that are happening here. So the first thing that you need to do is determine, am I just comparing a mean or a median, we'll talk about in a minute, to a value? Do I have two groups I'm comparing to each other and they're completely separate? They don't pair up. Or do I have two groups and it is paired? Or is it three groups, whether paired or grouped or not? And so that's what I need to determine first. The next thing I need to determine is whether certain assumptions might be met for my data. The first thing is this, okay? Is the data that you're comparing interval ratio? Suppose it's something like a test score. A test score is interval ratio, okay? Or an age, or a height, or a weight. Something like that is interval ratio. It is interval ratio. If it meets the threshold for either interval or for ratio data. Essentially, to meet the threshold for at least being interval ratio data, differences between sets of values have to have meaning. Okay, so the difference between an age of 35 and 42 has meaning, 7 years, okay? Well, the difference between, being in, ethnic group white versus ethnic group Asian has there's not anything you can just subtract a numerical value that has meaning. So it must be interval ratio. If that's not the case, if instead I do have ordinal data, then I'm going to bump down to this last row here. So if I have ordinal data, so maybe I have categories where the ordering makes some kind of sense. Maybe it's something like your outcome variable, something like highest level of education, and you have, less than high school is 1, and 2 is high school. 3 means some college, or technical school. 4 means they got a college or technical school degree. 5 is graduate school. If you have something in that level that's ordinal, then you immediately are going to bump down to this row 7 here, regardless of what other criteria that I'm going to talk about are met. And you're going to do one of the tests that's appropriate for which of the 5 cases that you have that's listed here. Okay? So we'll come back up here. This is our simplest case. And so once we've established that the data is interval ratio, I'll either be in this row 3 or row 4 now. To be here in row 3, the data has to be normally distributed or a sample size of 30 or larger. Okay, so if the test scores are normally distributed, doesn't matter how big the sample is. If, however, the test scores are not normally distributed, and normally test scores are not normally distributed, they're usually very skewed left, then you would need at least a sample size of 30. Otherwise, your results are going to be inaccurate. So that's the case for both of these rows here. And if neither of that is met, again, we're going to bump down to this row 7. So we'd be in this row 7 down here, and I'll talk about what all these mean here. Maybe because it's not normally distributed test scores and I only had 18 participants. So then I'll need to use this lowest row here, regardless of which of the 5 types of situations I have, just 1 mean, 2 samples paired or whatever, it'll fall into this last category. Okay, and then the last thing that we're going to look at is whether or not we have equal variances amongst the groups. That doesn't apply here because there's only 1 group. Okay, so don't worry about that. It does apply when I have 2 separate groups or 3 separate groups that I'm comparing. When I have this pair data, it doesn't apply again, and the reason is because what we are really going to do is for these pairs find a column of differences, and as if we have 1 sample, 1 group, it's just 1 column of data that's differences, and again, there'd only be 1 standard deviation, so there couldn't be a difference in standard deviations or variances between the 2 groups. And if I'm in this last case over here, 3 means or more, then it's going to be, we're going to look at something more complicated called sphericity instead of looking at the equal variances. If equal variances are not met, we go down to this row right here. Okay, so we will, amongst all these factors, the things that are true determine which of these various tests we do. So what we're going to do now is let's start off with, let's just like 1 mean compared to a value. Okay, so I want to test if the mean on some test score is still equal to 78 or whether it's changed. So we're just, that's the basic test. If all these criteria are met, okay, then I do a student's t-test. Now you see that's the same in this next cell down here, and the reason that it's the same in this next cell down here is because I just have 1 group, so I'm not going to really be able to do the equal variances test. So all I'm really doing is looking to see, do I have a normal distribution greater than 30 and interval ratio? So I'm looking at test score, it's interval ratio. Okay, my sample size is 18. Okay, now what do? Well, it depends whether now the data is adequately normally distributed. And there's a variety of tests you can do to look at that. The best thing that I suggest doing, just as a basic here, I may have other videos at other points talking about testing for normality a little more rigidly or formally. But generally what you want to do is just look at a histogram of the data and look, this is approximately, roughly bell-shaped. It's not going to be exact with a sample of 18 by any means, but does it look like it's not extremely skewed or something? Extreme skewness would be a concern. So you basically want to make sure the data doesn't look extremely skewed for the most part. If your sample size is less than 30, okay? If it's greater than or equal to 30, you don't even have to worry about that. You know the student's t-test is fine. Okay, now down here, what we end up doing if we don't meet those criteria. So let's say that it's the data is less than 30. Say it's 18 again, and I find it doesn't look normally distributed very well, looks quite skewed. Then to get more accurate results, in other words, more accurate p-values when you're done, you're going to want to do this Wilcoxon signed rank test. Instead, it actually tests whether the medians are equal or whether instead of the means are equal. So again, with one sample, whether I have ordinal data or whether I have data that just doesn't meet the criteria here of being normally distributed or greater than 30, doesn't need to be both, just or, then I would use this Wilcoxon signed rank. That's the case in which you would use that. And most statistical software will do that. At some point I'll have a video on showing you how to do that in various softwares, but at this point, just be aware most softwares will do that test. You need to look for that. Okay, now let's go this two means independent samples. That's where I've got maybe males and females and they don't pair or group in any particular way. Then what I'm going to do is, again, I look to see whether these criteria are met. If the data is ordinal, it is not adequate, it's not interval ratio, I immediately skip down here. If not, I'll look at this if it's interval ratio and I'll say, okay, sample size, let's say sample size greater than 30 and an interval ratio, then the only other thing I need to look at here is whether my two groups have approximately equal variances. Okay, approximately equal variances. And there are a lot of, again, tests that can be done to do a test of that. There's a Levene's test people often do that tends to be too sensitive, meaning it will come out as statistically significant, telling you the variances are different when the practical significance is small. In other words, the difference between the two groups is really quite small. One guideline that's sometimes used is if the standard deviation of the two groups is not more than one double the other, you're probably okay, right? But if we do end up with, so that's the student's t-test if all that's met. If we still, it is normally distributed or bigger than 30, okay, either one of those is met, and interval ratio, but I don't have the equal variances, then I do this Welch's t-test instead. And again, most software will do that for you. Okay, it comes out as an option in most software. You interpret it the same way the student's t-test. It looks the same very much. It's just a slight adjustment to take into account the lack of equal variances. Okay, so that's what we do there. Now let's say we have paired data. Paired data works very much like this column B, the one mean. And again, that is because what is really being tested is whether, if I find a column of differences, that column of I'm treating that column of differences, as one column of data, and I'm looking to see whether the mean of those differences is 0 or not. Okay, so that's what I'm literally looking for in this particular case. Again, I'll use a student. I won't test really to see the variance is equal because there's just one group of differences when I'm done. But I will look to see, do I have interval ratio data? If not, I jump right down here to this particular test. And I look to see whether my sample size, the number of differences I have, the number of pairs I have, okay, is greater than 30. I should say back on this one, you need both groups to be greater than about 30. In this particular case, so you need 60 at least altogether, right? Each group. In this particular case, same thing. Unless you're doing multiple measurements on the same person, then you just need 30. You need column of differences of at least 30. If it's smaller than that, then it's normally distributed. If that's not met, we pop down here. Now this test, okay, the Mann-Whitney U test or Wilcoxon rank sum test, and this Wilcoxon signed rank, these names are all really similar to each other, but those are all available in most statistical softwares. Those are the ones you want to use. Okay, so now let's come over here. So let's say I have 3 or more groups, independent samples in this case. So I have 3 gender groups, 3 ethnic groups, 3 treatment groups, anything like that, a control and true treatment groups. And essentially my null hypothesis, all means are equal. Well, the alternative is that at least one mean is different from the others, okay? That's what I'm looking to find out, is at least one different. I'm going to do if the assumptions are all met in one-way ANOVA. Okay, and again, the same kinds of things are the case over here in terms of the requirements. I need interval ratio data. If not, I'm going to pop down here. Okay, I need approximate normal distribution within each group or large samples. If not, I pop down here. Okay, and then I need equal variances amongst the three groups. And if not, I pop right here. So the difference between this row and this row is always that equal variances row requirement. And you'll see again the here and here doesn't matter, but in these two cases it does when I've got those independent groups. And these are corrections that are made to the ANOVA if this variances aren't equal. And again, I can use various tests like a Levene's test, but one commonly used guideline is just to look at the standard deviations of the various groups and see whether there's the biggest one is more than twice the smallest one. If not, you're probably fine. Okay. And so that's a basic guideline there, and that's the test that you would use or the correction really to the test that would be done if the standard deviations aren't equal. And again, if you don't meet the normality or sample size, then you're going to go with, or if the data is ordinal, you're going to use the Kruskal-Wallis. Okay, and then we come over here, repeated measures. A repeated measures ANOVA is what you would do in this case if you have all these various requirements met. Except for we don't really look at equal variances because it's a more complex situation than that. We look at something called sphericity that can be calculated by most statistical software, and we want a value less than 0.75, okay? And if that's not the case, it's sort of like a multidimensional equivalent to looking at equal variances. It's something much more complicated. Then we look at this correction if that's not the case. And again, if we have ordinal data or we have trouble with the normality or sample sizes, then we come down and we do this Friedman test instead. So those are all the various options you can use for comparing means or, when necessary, medians in place of the means, depending on the structure of your data for these particular most common types of cases.